Okay, our 5.5 notes are going to deal with the zero product property and how we are going to find solutions using factoring. Right, if you remember from 5.2 and 5.3, we talked about the different ways we can factor. We talked about using the x, splitting the middle, and then factoring by grouping. We are going to take that one step further now in order to find our solutions. If I take two numbers, right, let's just call them A and B, and I do A times B, and I say that they are equal to 0. One of the following has to be true. A might be 0, B might be 0, or they both might be 0. So the zero product property says, with something like this, if you're setting two things that are multiplying each other equal to 0, then either this is equal to 0, that is equal to 0, or they are both equal to 0. Here, if I had x minus 3 is equal to 0 or x plus 5 is equal to 0, right, we can kind of forget that there are parentheses involved here, right? So that's just x minus 3 is equal to 0 or x plus 5 is equal to 0. How would we solve? Well, what you do to one side to get rid of something, you need to do to the other side, right? So I'm going to add 3 to both sides because I want to get x by itself. I'm going to subtract 5 from both sides because I'd like to get 5 by itself. Your solution would be x is equal to 3 and x is equal to negative 5. Putting these together and saying that they were multiplying each other doesn't change too much about how we would solve here. It's either x minus 3 is equal to 0, x plus 5 is equal to 0, or in this case, when we're solving, both. Right, so we need to find all possible solutions. One of them will be when that is equal to 0. One of them will be when that is equal to 0. And then you just solve exactly like we just did. And we come up with two answers, right? One answer, x is equal to 3, and one x is equal to negative 5. If I took this 3 and substituted it in for x, it would make that whole thing 0. I would have 3 minus 3 times 3 plus 5. Well, 3 minus 3, that's 0, times anything, doesn't matter. 0 times anything is 0. So I can go ahead and substitute that back in to check and make sure that my solutions are correct. I would like you to try D and E. So please pause the video for a moment and try these, and we will come back in a minute and go over them together. Hopefully you paused it. I'm going to take x minus 3, set it equal to 0. X plus 6, and set that equal to 0. And then I'm just going to solve for x, right? Two different solutions. Here I'm going to add 3 to both sides. Here I'm going to subtract 6 from both sides. And I get 3 comma negative 6. Over here for problem E, same thing. I have 2x plus 4 is equal to 0, and x plus 1 is equal to 0. And I'm just solving for x for both of these. Here, we're going to have a one-step, right? You just subtract the 1, x is equal to negative 1. Here, we're going to have a two-step. I first need to take care of that addition, right? How do we take care of addition? We subtract. And then I have 2 times x. To get rid of multiplication, I divide. Divide both sides by 2, and I get x is equal to negative 2, x is equal to negative 1, and those are my two solutions. For problem F, we can put parentheses around that x. It really doesn't matter. We could also rewrite it in a way that it looks like some of these other ones that we just saw. You could rewrite it x plus or minus, doesn't matter, 0. 3x minus 9 is equal to 0. Right? It doesn't really matter. This x plus 0 is the same thing as just saying x. So we don't really need to waste our time with that. Same thing. I have x is equal to 0. I have 3x minus 9 is equal to 0, right? It's either x is 0, 3x minus 9 is 0, or they are both 0. X stays as 0. We add 9 to both sides. Here we're going to have to divide by 3. After we divide by 3, you're going to get 3. So your solutions are 0, comma, 3. This is the zero product property. When you have two things that are multiplying to each other and set equal to 0, one or both of them have to be 0. Now, how does this help us with trinomials, with quadratic trinomials? Well, what we talked about, and you can go look back on days 5.2 and 5.3, we could have found solutions for any of those examples. Because at the end, after we factor these, 9 times out of 10, we end up with two products equal to x, right? Or equal to whatever we want. Now we're setting them equal to 0 because we want to solve them. First, I need to factor, right? So we're going to factor using the x and then splitting the middle. I'm looking for two numbers that are going to multiply to a times c, so that'll be -6, and add to -1. They multiply to a times c. They add to -1. That's going to leave only one option. That's got to be -3 and +2. Make sure that you're not flipping which one's positive and which one's negative. Right? -3 plus 2 will get me -1. However, +3 minus 2, or plus -2, would get me +1, which is not what I want. I do that so that I can rewrite my equation. I can rewrite my quadratic as 3x squared minus 3x plus 2x, right? This minus 3x plus 2x is coming from these two numbers right here. Your a stays the same, your c stays the same, and we're setting equal to 0. From here, now we move to split the middle. I'm going to cut my equation in half and create two binomials. 3x squared minus 3x, 2x minus 2. I'm going to factor both of these. What do both of those terms have in common? Well, I have a 3x squared and a -3x. I can take out a 3x from both of these terms. Think about what you're leaving behind. If I take out a 3x, I will only leave behind an x. If I take out a 3x, I will only leave a -1. So I should be leaving a 3x times x minus 1. For the next part, right, again, we're still factoring. Find your greatest common factor. The only thing that I can take out of both of those is 2. What do we leave behind? Well, we leave behind an x minus 1. And it's been reiterated before, and I'll say it again. It's at this point where we can tell whether or not we're doing the right thing. I was able to take out a 3x and a +2. But what I left behind, x minus 1, that matches up. If it doesn't match up, then we may have made a mistake. Now we're going to group. We're going to group what we were able to take out, 3x plus 2, and what we had to leave behind, x minus 1. And now hopefully here is where you can see, okay, we've done this before, this was on our quiz, but now we're going to take it one step further and solve for each of those x's by using the zero product property. It tells us that 3x plus 2 is equal to 0. X minus 1 is equal to 0. We can solve for x for both of those. My first step right here would be to subtract 2 from both sides. My first step here would be to add 1 to both sides, and then I'm actually done with that on the right. Last step here would be to divide both sides by 3, right? And I have -2 over 3, and I could just leave it as -2 over 3. So one of my solutions is -2 over 3. My other solution is 1. We'll go over maybe 2 more, we'll see. But these are ones that I want you to try yourself before just immediately jumping to copying down what I'm doing, right? For this second one, if you try it, please make sure that you are rewriting this. I know this would be one that some of us can factor out really well, but I'm not going to talk through that because there are some of us that wouldn't be able to factor this well. Instead, we can rewrite it. X squared plus or minus 0x, because there were 0 x's here, minus 64. And now I'm looking for 2 numbers that are going to multiply to negative 64 and add to 0. Think about what numbers those could be. Might be easier than you think. Negative 8 and 8. Negative 8 times 8 is negative 64. Negative 8 plus 8 is 0. And now we just did that to rewrite our equation. And again, from right here, what I would like you to do, if you have not yet, pause the video and try factoring this yourself. Factoring using split the middle, try doing that yourself. Go for it. Split the middle, you're looking for the greatest common factor, x squared minus 8x. That's just going to be an x. Looking for the greatest common factor, 8x minus 64. That's got to be 8. So what am I able to do? I'm able to take out an x and a positive 8. That's highlighted there in red. X, positive 8. What did I leave behind? X minus 8, x minus 8. Do they match up? Yes, they do. I know I'm on the right path. And then I factor them by grouping. I took out an x plus 8. I left behind an x minus 8. Zero product property tells us that we can just take this, set one of them equal to 0, set the other one equal to 0, right? I have x plus 8 is equal to 0, and x minus 8 is equal to 0. I get x is equal to negative 8 and positive 8. Again, there are other ways that we can factor this quadratic. However, we can stay consistent using this. Okay. Looking at 3 or looking at C just a little bit, and I want you to try both of these yourself. However, with this first one right here, think about what we can do right away that might change our quadratic. Hopefully in your head you're saying GCF. Absolutely. I'm able to take a 2 out here, take a 2 out here, take a 2 out here. And I have 2 times what's left behind. X squared minus 4x minus 12 is equal to 0. This 2 has to just stay in front for the rest of the problem. It's not a part of any other step, right? Split the middle, grouping, anything like that, but that 2 just stays outside. We were looking for 2 numbers that were going to multiply to 1 times negative 12, so negative 12, and numbers that were going to add to negative 4. Those 2 numbers are negative 6 and positive 2. We can use them to rewrite our equation. Notice how that 2 still is hanging out on the outside. And then I have x squared minus 6x plus 2x minus 12 is equal to 0. From where you're at right here, I would love for you to give this a try. Pause the video, go ahead and give it a try. Just kind of showing you here. When you split the middle, again, 2 stays right out in front the whole time. I'm able to factor out an x. I'm able to factor out a 2. I leave behind an x minus 6. So I group x plus 2, x minus 6, and look who's still hanging out, the 2. Right, that 2 is still hanging out because it's our GCF. We took it out earlier. It's got to stay. Now we have 3 things multiplying equal to 0. Right, that would maybe be a times b times c is equal to 0. Well, just like it was with 2 terms, a is either 0, b is equal to 0, or c is equal to 0, or it's 2 of them or all 3 of them. In this case, you have 2x plus 2, x minus 6, and all of them are equal to 0. One of these can be ruled out right away. Clearly, 2 is not equal to 0. So our solutions here would be -2 and 6. And then for our last one here, I'll leave it up. There's no GCF. There's nothing necessarily special about this example, but all we do at the end, right? We all did so well on the quiz, which is great. All we do at the end of our factoring is just set the 2 equal to 0. That's it. Now, there is a word problem here that I would love for you to try, so please go ahead and go for it. We have to come up with the equations ourselves. This is one that we definitely struggled with in Unit 4. Okay. The area of the rectangular pool is 1,260 feet squared. We need to find the dimensions of the rectangle. One side of the pool is 48 feet more than 3 times the other side. That is a very helpful piece of information. 48 feet more than 3 times the other side. Here's what our rectangle could look like. Our other side we can just call x. And one of our sides is 3 times more plus 48. Right, again, that's 48 feet more, but plus 48. Then 3 times the other side, there's your 3x. Write an equation for length in terms of the width. Well, we just did it right here to come up with a picture, right? We can say that the length is 3x plus 48, where your width is just x. When we are finding the area, right? Area of a rectangle, and this isn't necessarily something that we have talked about, but your equation for an area of a rectangle is length times width. In this case, your length is x and your width is 3x plus 48. So I can just take that x, distribute it. That's how I get 3x squared plus 48 times x plus 48 times x. The area in this case, we were told right away, it is 1,260. And we want to solve for x. And in order to solve for x, we got to have something equals 0. Right? We can't have something that's equal to something else. So what I can do is I can take this 1,260 and let's move it over to the right. So now I have 0 is equal to 3x squared plus 48x minus 1,260. Now, before I go through it, I want you to give that a try. I want you to try to factor out that trinomial. Think about what you might have to do first. Take out the GCF. make the problem a lot easier for yourself. Okay, instead of looking for numbers that are going to multiply to 3 times negative 1,260, I'm looking for numbers that multiply to 1 times negative 420, significantly less numbers. Instead of them having to add up to 48, they have to add up to 16. This would be a tough one to have to go through yourself, right? Going through all the different numbers that can multiply to negative 420, seeing which of them will actually get me positive 16. But those two numbers are negative 14 and positive 30. And now what I would like you to do over here, if you have not yet, split the middle, group, and see what you get for your solutions. That 3 hangs out in front because that 3 is like a little brother. It's got to hang out in front now. I have x squared minus 14x plus 30x minus 420. I split the middle to make 2 binomials. GCF here is just going to be x. What do I leave behind? X minus 14. GCF here is 30. What do I leave behind? Another x minus 14. Check. X minus 14, x minus 14. I'm on the right track. Now I group. What was I able to take out? X plus 30. What did I leave behind? X minus 14. And now I have 1, 2, 3 things that are going to get me 0. Is 3 equal to 0? No. X plus 30 is equal to 0. Well, then x has got to be negative 30. X minus 14 is equal to 0. That means that x is 14. Now we have our two solutions, negative 30 and 14. Now, thinking about the context of this problem here, right, we're looking for area of a rectangle. We're looking for a length and a width. Our x can't be negative, right? Can't have a negative length, can't have a negative width. So those are the 5.5 notes. What I would like you to do now is go into the worksheet packet and go ahead and get started on the 5.5 worksheet. I would like this to be done by next class. So all the way until page 253.